Hi guys, good morning. Today we're going to find a missing side in a geometry lesson. We're going to find a missing side in a right-angled triangle. This is called the Pythagoras theorem. The right-angled triangle has one right angle and a very special side called a hypotenuse. Now, your hypotenuse is always going to be your longest side, and it's always in a right-angled triangle. We know that this is a right-angled triangle because we can form a little square right here, which forms an angle. Your hypotenuse is your longest side of this right-angled triangle, and it's always going to be on the opposite side. So I'm going to label this hypotenuse because it is on the opposite side. So there's my hypotenuse. Over here, figure B. Here's my right-angled triangle. Now I've got to find my hypotenuse. Well, my hypotenuse is on the opposite side. So here is my hypotenuse. But I immediately noticed something differently about this hypotenuse and this hypotenuse. Do you see it? I do. This hypotenuse has already been provided with a measurement. It is 8 centimeters long. Whereas on this side, I'm sad. I don't have a measurement here. So it is unknown. Now, we like to use a certain variable, a certain letter of the alphabet for an unknown side. I like to use X. So I'm going to say that this is X because it is unknown. I'm going to write an X here on this side because this side is unknown. So I'm going to place an X because we're solving for X. Now, most of you may be already familiar with the Pythagorean theorem. The formula for the Pythagorean theorem states that a squared plus b squared equals c squared. So we could use a and b. This is a, this is b, or this is b, and this is a. It really doesn't matter. Or we could say that this is side A and this is side B, or this is B and this is A. It really doesn't matter, but we're solving for C, which is the unknown side. Yes.
If we're solving for one of the sides and the hypotenuse is already measured, so wouldn't the hypotenuse be C?
Yes, the hypotenuse is C. Well, the hypotenuse is C. You're absolutely right, but C on this one is already solved. Okay? All right? C is already given here. On this one, C is not given. So C is missing. So you are absolutely right. Got it? Now, I may show you another video where they're actually using a squared, b squared equals c squared. But this is where I'm getting your a and b. But most importantly, I just want you to remember that you're solving for a missing side. Okay? Now, Pythagoras came up with that rule because he said that the totality, once I square this side and this side, is going to tell me my missing side. So now that we know all of that, we need to go ahead and try to write this out using the rule and creating an equation. The Pythagoras theorem demonstrates that a certain relationship, and I just went over the relationship and told you that there's a relationship between the sizes of the triangle. Now, whenever you are looking for the hypotenuse, just add it. Always add. ADD. Whenever the hypotenuse has already been given and you're looking for either an A or a B, just subtract. Just do it. Just subtract for me, okay? So I'm giving you that rule because it's so important. I'll say that again. If the hypotenuse is already provided, subtract. Over here, if the hypotenuse is not given at all, add it. Now watch what I do. Here we go. I'm going to bring down my x squared, okay? And I'm going to write my 3 squared because this is a side. So remember I said just add it. Plus 7 squared. No, I'm sorry. A squared, that's an equal sign, I apologize. A squared equals 3 squared plus 7 squared. There you go. X squared equals 3 squared plus 7 squared. Now we're going to move our x squared back down, and we're going to multiply this number by itself. What's 3 times 3?
9.
9. What's 7 times 7?
49.
Bring down my x squared. If I add 49 plus 9, what do I get?
58.
58. Now we're not quite done yet because there was one more step that we have to do, and it's called taking the square root. We've got to now take the square root. That's the last step of that 58. And we know that when we start taking square roots, we need to know whether it's a rational or an irrational number. This is an irrational number because it's not a perfect square. So we're going to have to take out our calculator and find that square root. But hang tight for just a minute. I want to kind of creep over here and look at this one right here, because we're going to solve that one a little differently. I'm going to bring down my x squared, and then I'm going to put my equal sign. Here's my 8 squared, that's side A. And then I'm going to subtract. Remember I told you, when the hypotenuse is given, just subtract. So that's going to be 8 squared minus my 4 squared, which is my other side. Bring down my x squared again. What's 8 times itself? 8 times 8?
64.
64. What's 4 times, subtract. Now we're ready to subtract. So what's 4 times itself? 4 times 4?
16.
16. So now we're going to actually do the subtraction. And that's going to be 16 from 64, which is
48.
48. Now I told you, now we got to take the square root. That third step is finding these square roots. So I'm going to take out my calculator. If you have yours, you can take yours out as well. Now, you're going to have to remember some rounding rules, because I'm telling you, we're going to get some pretty long numbers right now. Because once you take out that calculator on the first one, you're going to press 58, put that in. Now, look for the square root symbol, okay? You're going to look for the square root symbol. And when you look for the square root symbol, you press it, and you're going to get a very, very long number once you solve it. And it's going to look like this. It's going to have 7.615. And then it's going to have 773. And it's going to just get long, 1057. And it's going to go on and on and on and on and on. Well, I can't use that. I've got to round that. So I don't need that whole answer. I just need to round it 2 decimal places. In this particular case, it would be 7.62. Because you got to take into consideration that 5 is in the third digit after the decimal place. Here's that 5. And remember, if it's the third digit, I'm going to have to round the second digit up. So my answer is going to be 7.62 because I had to round it. All right? That's where I got that. Now, same thing with this. We're going to put that in the calculator, 48, because 48 has no perfect square. So when we do the math on that calculation on that, you're going to come up with another long number. It's going to be 6.9, and it's got all these numbers after it. You'll see 282032. That's what happened when I did it. It goes on and on. Well, I've got to round that too, and it's going to round to 6.93 because of that 8. It's going to be 6.93. Guess what, you guys? We are done. We have solved using the Pythagoras theorem. We have followed the steps. I want to go back through it because you got homework and you're going to be practicing these on your own. So here we go. Step 1, look for the hypotenuse. Remember, the hypotenuse is your longest side. Here is my longest side, and it's opposite of my right angle. So I label that hypotenuse. Because I do not know my hypotenuse and it was not already measured, I knew I had to add. Then when I creeped over here and looked at this one, I saw that I needed to look for my hypotenuse. Here's my longest side because it's opposite my right angle. But guess what? I already had the measurement for my hypotenuse. So I knew over here that I needed to solve for this either A or B. But this is my missing side. So when you know your hypotenuse is not already be given, what do? Subtract. Subtract. So this is adding, this is subtracting. So step 1, just bring it down. X squared equals 3 squared plus 7 squared. I square my numbers, and then I add, and then I take my square root. Over here, I subtract, bring everything down. I got 48, and I find the square root. And make sure you round your decimal. Round that decimal. Okay, guys, I hope you've learned a lot today. Get busy. Talk to you soon. Bye.